Welcome to our presentation on processing power lines with LP360. Today we'll be reviewing data collected with the TrueView 515 by EDP Brazil, one of the largest Brazilian electric utility companies, and then we'll see how it's been processed with LP360. LP360 is our advanced desktop LiDAR and photogrammetric point cloud processing software that makes it easy to extract data and develop products from point clouds. Our presentation is around 20 minutes, where we'll demonstrate how LP360 can help identify, classify, inspect, and then assign encroachment zones to a 5-kilometer stretch of power lines. The end result will be a complete dataset where the user can quickly navigate to your encroachment points and transmission towers, conduct visual inspections of the area, and make decisions about the encroachments and any other areas of concern. If you have any questions during the presentation, please submit them in the GoToWebinar chat on the left-hand side of the screen, and we'll have a response for you within 24 hours. Then at the end of the webinar, we'll also show a quick fly-through of the point cloud in a data viewer. But first, let's take a look at the TrueView 515 in action before we begin processing in LP360.
This is data collected for EDP Brazil using a TrueView 515 in April of 2022. This is a section of line where we've gone through and processed the data, done wire extraction, which is collecting, identifying the hits on or returns on the wire, vectorize those to create catenary curves, essentially vectors that represent those wires, and then run an encroachment check along those wires to find objects, trees, other wires, so forth, which were within certain distance or danger zones. In this particular example, we're using danger zones of 10, 7.5, and 5 meters. And I'll walk you through what that data looks like and hopefully give you some good visuals. So this is the overall data set. This is 1 day of collect. It's about a 5-kilometer stretch of line. It was a total of 4 flights during the day, and they flew 2 passes. So they went, southwest to northeast, and then northeast to southwest, either side of the main line. All the data has been processed in TrueView Evo to get the colorized point cloud and ensure that all the geometric corrections are applied, and we have a good point cloud data, and we're picking up from that point. So this is my laser point cloud, colorized by elevation, of course. I'll just zoom in a little bit on this central section so it's a little bit easier to see what we're looking at. So we have a central string that we have created from the data, which actually is important as well, but it includes a vertex at each tower location. We'll see that in a little bit. And that captures the XYZ location and also the height above ground of the top of the tower. So this is additional value add that we're giving back to this particular customer. And it's the main tower alignment that we use for generating the wire extraction and so forth. And if I look at this in profile, we can see the data that we've actually got. So now we're looking in profile. You can probably notice there's actually 2 lines here. So it's this main central line that we're interested in. You can see at the back, there's probably some distribution or maybe even telephone lines back there. They're off to the side here. We're not too interested in those. Across the top, you can see our tower alignment, but you can sort of see, certainly as we zoom in, we've got good returns from all of the wires. We've got good returns from the towers. I'm going to thin this up a little bit, maybe to get rid of that tower line. See how this looks. Yeah, there we go. Okay, so that back line, that was just some secondary lines that we're not that interested in. So we have um, some good data returns. We've got good coverage on even on the top wire here, and of course we've got lots of coverage from the ground. We can look at this in an isometric view as well. If we look in, I think in about here. Yeah. So we can see we've got a tower here. There's that secondary line that I cut out. See if I can get a good shot of the tower. Trees. That's the secondary line. And there's the tower in there. So as I mentioned, we do wire extraction. We go through and we run what we call wire extraction. That's a point cloud task that essentially has an algorithm that goes through and detects hits from the wire, but will also classify them into our wire class. So that's already been done here. So I'm going to switch to a class view here in my profile. So you can see my wire hits are now these green points up here. My towers have been classified out. We do that manually. It's not done by the algorithm. And they have some color coding here, which I'll explain in a few minutes. That's basically the encroachment zones that I mentioned. This blue here is the furthest zone, the safest zone. That's stuff that's 10 meters away from any of the wires. The algorithm also vectorizes those. If I turn on these, you can see that we have individual vectors here for each span. If I show a full span here. So we have these vectors that represent the wire segments, the catenaries from tower to tower. And we can use those to do our encroachment check. So as I mentioned, for this particular client, we are using 3 different encroachment zones. That's 3 different danger zones. Zone C, the furthest zone, is anything that's within 10 meters of the wire. Zone B is anything that's within 7.5 meters, and Zone A is anything that's within 5 meters. Anything that's further than 10 meters away, we're not concerned about. So we can run the classification along the wires, and this is probably a little bit easier to see in the top-down view. So I'm going to switch my top-down view to colored by class, and it may actually even be easier if I switch this to a surface view. Right. So now the color coding that you're seeing here, and I'll turn off my vectors. Again, just visually, it's a little bit easier to see here. So there's the center of my corridor. Anything that's blue is essentially, as I say, it's that 10 to 7.5 meter zone. It's encroaching a little bit, but it's not something that the customer is particularly worried about. Areas of yellow are between 7.5 and 5 meters to the zone. And you can see as you get larger growths of vegetation, you get closer and closer to that. And then, of course, there are areas, I think there's some areas up here, which get into zone A, which is our danger zone. All right, you can see we're starting to get some stuff that's within that danger zone. Now, of course, the top-down view is not really the best way to look at this or review this. So we have some tools in Evo that help the operator go through and review all of these encroachment zones, what we call these danger points, and look at them and see, just exactly how dangerous that encroachment is. So I'm going to set those things up here and show you how we walk through some of the data to allow the operator to efficiently go through and scan through a segment like this. So the first thing I'm going to do is I am going to draw a profile again. And I'll just take a profile. I'll just set it up across here for now, I think. Don't want it too thick. There we go. I'll zoom out a little bit. Make this a little bit wider. This may be an example where, we have some flexibility with Evo. I think for this actual exercise, I prefer to make a sort of a taller but narrower kind of profile. The color coding that you're looking at here, so these are obviously our wires up here. We're in the middle of the span here, so you're not seeing a tower. So these are our different wires. And then the color coding here is based on those encroachment zones. So again, blue, 10 to 7.5, yellow, 7.5 to 5, and we don't have any danger, any zone A points in here. What you can do in Evo is, so here is we call them cluster points, but these are basically my danger points. It's essentially a shape file, a feature layer in your map. And if I just drag this over here, I'll just show you this and then I'll move it back off to my other screen. So I have a group of points. We've essentially run an algorithm that identifies all of the points within our different danger zones and then clusters them, or basically creates a single point so the operator can drive to that cluster, that encroachment, and look at it and make some decisions. That way the operator doesn't have to deal with all of the many points that you'd have in these clusters from this dense kind of LiDAR data. So you can see I've actually identified 23 different encroachment areas, danger encroachment areas along this line. And what I'm going to be doing is navigating through this list using these navigation controls and driving my map to that so that I can look at it. And I can do that by selecting points here. So for instance, if I just select a point randomly here, you'll actually see the map moves in the background. And if I move this out of the way, you'll see that my profile has moved here. So what you're going to see here is as I'm navigating over here off screen, we're going to drive to these different points as we go through them. And I'll increase my, let me zoom in a little bit closer here. So I can say I do actually have some red 5-meter danger points in here. They're obviously close to this wire. So to systematically move through and look at these encroachments, I would start at my first point. So I'm going to select my first point. I'm going to drive to that. It's right at the end of my my data collect and my tower and span. So it's not really a true point. It's just looking at the edge of the tower. I don't really need that. So I can quickly navigate to my next point. And so we can see right away, okay, so we've got a pretty big growth in this area that's within my 5-meter danger zone, obviously close to this tree. So I could make some decisions here at this point. Do I need to flag this for a field crew? Whatever I'm doing in terms of the output from my review, I can be taking that. And so you get the general idea. I can navigate through these cluster points. All I'm doing off screen is just selecting the next one or navigating to the next point, and it's driving through these different points to show me what it actually looks like, and I can be making some decisions about that. Now, I'm not going to go through the whole line. Obviously, I said there's 23 or 24 encroachments in this 5-kilometer stretch, and of course, those zones that I mentioned are definable. Obviously, each customer may have a different series of zones they want to look at, different criteria for how close they want to flag things getting to the line. So here we do have a danger point, but you can see this isn't actually vegetation. What we have here right here, it looks like that's probably a road. So this is the point I'm looking at in my map view. So we've just got a wire that's crossing underneath my actual wires that I'm interested in. And this may or may not be of interest to the customer. This may be something they're trying to flag. Obviously, it's a fairly dangerous encroachment in terms of distance here, but this isn't growing vegetation. This line isn't going to suddenly, next year be up here. But it does let you see that the LiDAR data, the point cloud data, and the algorithms that we're applying in Evo do capture, these objects that are close to your wires, which is really what you're interested in. So again, you could walk through all of your different encroachment zones and make some decisions about each based on the process that the customer would have in place for these encroachments. The other thing that you can review, of course, so encroachments, things typically trees growing close to our wires, we're interested in that. We're also a little bit interested in the towers. Now, this data was not collected for any line engineering or any tower engineering. The catenaries are primarily used for just detecting encroachment. They're not necessarily used for the high accuracy line engineering work that you might do, say, if you're going into PLS CAD. But we can go look at the towers. And the way that I'm going to do this, I do have the tower string. So I mentioned this tower alignment. I'm going to bring that up in Feature Analyst again. And again, just so you see what I'm seeing on the other screen, I have a line string here, which is essentially my tower string, my tower alignment. Each of these vertices corresponds to a tower location. Okay, so if I drive to a particular vertex, I'll move it off screen again. You can see that I'm driving to a particular tower location. So I can see my towers, and if I wanted to, I could zoom in here, to take a look at the actual point cloud. I will point out we do capture in this particular workflow for this particular project, we do capture the actual tower height. Now, this particular project is quite close to sea level, so the actual Z elevations are quite similar to the tower height. Is basically, the ground's pretty much at zero here. But we do capture these actual tower heights as M values, so as attributes on the tower. So you have both an XYZ location at the top of the tower, but you also have a height measurement for that reference point from the ground as well. So you can use this to navigate through, similar to we did the danger zones, the encroachments, the cluster points. I can navigate through these. The general tool, of course, is you can move through and look at these. So here's a tower where we've got some undergrowth growing in here. It was all in zone C. It's all that 10-meter stuff. It's not of any danger. So you can inspect at least the general point clouds on the towers in this manner as well. Now, With the TrueView system, you capture both the point cloud, the LiDAR data, but you also have the imagery. So you have two oblique cameras that are capturing imagery at the same time. We want to make use of that information as well because we have that imagery. We may as well use that. So we do have, and because there were 4 flights here, we do have our oblique images. I've brought these in, so I'm going to turn these on now. In the map view, you just see essentially the photo centers. So these are the exposure centers for the cameras during the flight. And as I mentioned, there was 2 flights, one in each direction here, one sort of southwest to northeast and one back northeast to southwest. So what I want to do here is I want to turn on my Image Explorer dialog, and I'm just going to click somewhere near this tower. So Image Explorer will drive to and find the closest oblique images to the reference point that you clicked in your map. In this case, I clicked near the tower, and I get a primary left and a primary right image, and then any other images within a certain, I think I'm set by range here. There's a couple of different ways you can apply how it filters out the image for that. The reference point that you see, the red, that's the actual mouse click I made, and of course referenced in each image. So you can come in, you can look at the images here. You can pan around here, of course. You can look at some of the, if I just want to fit that back, you can look at, for instance, if you want to go in and look at the actual image EXIF information, you can do that as well. So it gives you a way to view these oblique images. So there's some additional tools in here I won't go over in this video, but you can make, for instance, make some measurements. If I wanted to make some measurements in here, I can make a single point measurement. I cannot digitize the features, but I can make a single point measurement. But the interesting thing about this is similar to the way with when I was navigating through the tower features, we can have our imagery update as well. If I'm back here and I want to navigate to a different tower, I can select a tower here, turn on my image drive mode. You can see the images updating at the back. So again, off screen, what I'm going to be doing is driving to my different towers here on my feature analyst. And what we'll see here is that in addition to my profile update, it will update and drive me to the particular tower that I want to look at. So that's a nice way to methodically step through and look at the different towers. You can get some pretty nice, if actually, I'll just put this large so you can sort of see some of the quality of the imagery here. All right. So if I'm looking at this, I can see my tower. I can inspect some of my attachment points. It's 20 megapixel cameras, so it's pretty nice imagery. And I can see where my reference point was as well. And I can zoom back out to my fit here. So again, a visualization way of looking at and bringing in that imagery. I can also do the same thing back to my encroachment zones. So originally when I looked at my encroachment zones, let's go select again, what we call cluster coverage. Load that up in my feature analyst. Make sure I've got my image driver turned on. Go select a point here. So we're doing the same thing now. We're driving again. As I navigate through my feature list, I'm driving both my profile. Although I probably need to have this turned on. Yeah, my profile and my image view to show me my cluster points. And now my reference point actually is it's the centroid of the cluster is the way the algorithm reduces it, but it's showing me where where I'm seeing or detecting this danger encroachment. Let's see, get this off here a little bit. There we go. So I can drive through these. Here's an example here. I can zoom in here again. I'll just expand just so we got a little bit more screen real estate. So I can certainly see here. Again, it's an oblique image. It's not a profile image or anything, but basically what we're saying is we've got a string of trees here, or bushes, not sure what those are, and they're getting close to this particular wire, at least within 5 meters in this particular case. We can see that here in the profile, and of course you can see it here in the map view as well. So if the operator wants to have the imagery up as they're browsing through, then they're perfectly capable of doing that. So we've got one here that looks like it's right under the wire, so they can see that. Now, in terms of geolocation or georeferencing of these points, okay, these are captured. So the X, Y, and Z values that we see here uh, are the actual georeferenced in the spatial frame of reference for the project that you're doing. This is UTM 24 South, I believe. So it's an actual real world location that you can then use to drive, field crew work or however you want to take this information and drive it into a downstream process flow. Also gives you the height of the centroid of the cluster, which should also give you some idea of just how high off the ground some of these might be. So in general, once you've got the point data classified, you've done your wire extraction, you've got your set of vectors that show you where your wires are, you've got your imagery to support that, you've gone through and done your obstruction checking, um, all of which is done through a point cloud task, which is essentially a macro or algorithm that you can run within Evo. You have a very nice data set that you can walk through. You can automatically drive to your encroachment points. You can drive to your towers. You can be making visual inspections of what's going on, and you can be making decisions about your encroachments and so forth. You can also be inspecting the towers and the imagery. And again, it just gives you a very valuable data set that contains a lot of information about the nature of the assets that you've been mapping. This was a fairly short stretch. This was about 5 kilometers, but of course you can imagine if you're doing a 20-kilometer or 50-kilometer stretch, being able to automate and drive through those points for inspection definitely makes you quite efficient in inspecting the data.
So as you can see, LP360 is a very powerful piece of processing software for 3D high-performance point clouds. Next, let's take a quick look at a visualization where we can fly through the point cloud of the power lines. In this visualization of the point cloud, we're using the Poetry viewer to see a rendering of the entire power line corridor. You can see there are still some high noise points that we further need to clean up, but overall this fly-through gives us a nice 3D perspective to view the entire area and see any of the points of concern. Well, thanks everyone for watching our presentation today. For additional information, or if you have additional questions about LP360 or our line of TrueView 3D imaging sensors, please email us at info@geoq.com. That's info@geoq.com.